the superposition theorem at 3 ohm resistor is, suppose now if you could keenly observe here, this 32 volts voltage source and 4 ohm resistor are seriously connected and in parallel to that particular combination 12 ohm resistor is shunted, and in parallel to the 12 ohm resistor 2 amps of current source is connected, and again 1 ohm and 3 ohm is seriously connected. This is the orientation of the electrical network. So in this electrical network we are going to use the fundamental laws. First point is the fundamental laws. With the help of fundamental laws I am going to determine whatever the current flowing through that 3 ohm resistor. So that is the first point. So current through 3 ohm resistor. So this is the first one, and this is with the help of fundamental laws. Second point is I am going to verify this current with the help of superposition theorem, that is SPST theorem. So in this SPST theorem, so how many energy sources are there? There are two energy sources. One is a 32 volts energy source and next one is the 2 amps. So if in the case 1, this 32 volts energy source I am going to make active, then if it is active, then we are going to make this 2 amps as inactive. So this is the first case. Then we are going to determine the current through 3 ohm resistor as I1. Similarly, in the second case, I am going to make this 2 amps of current source as active, then 32 volts voltage source as inactive. Then in this particular case, again I am going to calculate the current at 3 ohm resistor, and that current is designated as I2. And verification means this current. So what the current we have calculated from by using fundamental laws, that is nothing but the I. It must and should be equal to I1 plus I2. If it happens, then we can say that the superposition theorem is successfully verified at 3 ohm resistor. So first one is, first thing is we have to calculate the current through the 3 ohm resistor by using the basic laws. The basic laws might be Kirchhoff current law, Kirchhoff voltage law, Ohm's law, mesh analysis technique or loop analysis technique, or star to delta transformation technique, or delta to star transformation technique, or else source transformation techniques, current through various elements, or voltage drop across various elements. Now out of these fundamental laws, you can use any one with which you people are more convenient. So, but ultimately the sincere appeal here is, now your technique must and should reduce the complexity of the electrical network much and much. And next thing is nothing but the solution should not make the solution should not, or the step, what are the basic technology you are going to use, that should not create more complexity, or that should not increase the complexity of the electrical network, and at the same time it should not consume more amount of time. So such that you have to choose a better technique. Here there is no algorithm, there is no step-by-step procedure to simplify the problems. So here, if you could observe here, this 32 volts and 4 ohm source is because the current source is there. Either you can go for 12 ohm and 2 amps. Now this is the one combination. Now you can convert this 12 ohm and 2 amps parallel combination to a voltage source with the help of source transformation technique, or else you can convert this 32 volts and 4 ohms resistor which are connected in series. So you can convert this combination into equivalent current source with respect to a source impedance or source resistance with the help of source transformation technique. So there are two possibilities are there. One thing is, either you can convert 32 volts and 4 ohm resistor to equivalent current and impedance, or else this current source, 2 amps of current source with 12 ohm resistor, you can convert this combination to equivalent voltage source or resistance. So there are two options are available for us. So what I am doing is, I am going to choose the conversion of voltage source into a current source. So this is the loop I am considering here. Now this loop I am reducing, I am converting into the equivalent current source with respect to one source impedance with the help of source transformation technique. So this 32 volts and 4 ohm resistor is nothing but, whatever the current here, 32 by 4 is nothing but 8 amps of current with respect to 4 ohm resistor. So I am replacing this here. So inside that box, one voltage source with respect to one series resistor 4 ohm, it can be converted into one current source having a magnitude of 8 amps and with respect to some source impedance. that is nothing but the source resistance. So how we got this 8 amps? Because there is a 32 volts voltage source is there. With this is the voltage source divided by the impedance or resistance, that is nothing but the 4. So finally we are going to get 8 amps as the current. So 8 amps is in parallel to this 4 ohm. So 8 amps and 4 ohm, this is nothing but the equivalent of 32 volts voltage source in series with the 4 ohm resistor. So that can be eliminated, or that can be equivalently replaced with one current source with respect to one source resistance. So 8 amps and 4 ohm. Now if you could keenly observe here, this 8 amp current source and this 2 amps of current source, both are moving upwards, and so this combinedly the total current is nothing but you can see as 10 amps. 8 amps plus 2 amps is 10 amps. Suppose if any current source, if it is moving in the downward, suppose let us assume this 2 amps current is directed towards down, then in that cases 8 amps minus 2 amps is nothing but the 6 amps will be the resultant current. But luckily in this case both the currents are moving in the upward direction, so the resultant current is nothing but the sum of the two current sources, that is 8 amps plus 2 amps. So the total current is nothing but the 10 amps. And one more thing is, this resistor 4 ohm resistor and this 12 ohm resistor seems to be parallel. So equivalent resistance is nothing but 4 into 12 by 4 plus 12. So that is 4 into 12 by 16. So 4 4 ja, 4 3 ja. So you can see, or you can replace this 4 ohm resistor and 12 ohm resistor, the parallel combination, with equivalently one 3 ohm resistor. That's what I am going to do here. So this is one current source, one resistance. So the current source is 10 amps and resistance is nothing but the 3 ohms. Again, this is a voltage source, because in the previous slide, if you could see this 10 amps and 3 ohm, it is a parallel combination. So if you are not convenient with this particular loop, you can convert this the 10 amps into 10 amps with respect to 3 ohm to equivalent voltage source, again with the help of source transformation. So the voltage is nothing but 10 into 3, that is nothing but equivalently that is 30 volts with 3 ohm resistor in series. So that is, this is the voltage source with the 3 ohm resistor. The magnitude is just now 30 volts. This is the 30 volts and this is the voltage source. In series with this, there is a 3 ohm resistor is there. Then again furtherly, now only the thing is, we have to calculate the current at this particular instant. So one voltage source, there are 3 resistors are there, 3 ohm resistor, 1 ohm resistor and again 3 ohm resistor. So finally the total value of the current is nothing but the 30 volts divided by 3 plus 1 plus 3. So totally 4.285 amps of current. So the total current we have calculated at 3 ohm resistor, that value we obtained with the help of basic principles, and majorly we have used only source transformation technique here. It is not mandatory we have to use source transformation technique. If it is required, we can use the other basic techniques like KCL or KVL or mesh analysis or Ohm's law, whatever it may be, with which you are more convenient and in which area we are more perfect. So again, just for the sake, because we are going to verify the superposition theorem, so for better understanding, again I am presenting here what is the definition of the superposition theorem. So many times we have discussed about this superposition theorem. Superposition theorem states that in any linear active bilateral network having more than one source, the response across any element is the sum of the responses obtained from each source considered separately, and all other sources are replaced by their internal resistance. The superposition theorem is majorly used to solve the networks where more than 2 or more number of energy sources are available in the given circuit, and all the sources must and should be connected back to back. So that is the condition. So majorly the superposition theorem reduces, or it will help us to solve or to analyze the electrical circuit if that electrical circuit consisting of more number of energy sources like voltage sources or current sources. So I am going to prove the superposition theorem, and finally the response at 3 ohm resistor must and should be equal to 4.285 amps of current. So this is the value. So let me verify here. So first thing is, I am going to assume that this voltage source is active. If this voltage source is active, then what about the another voltage source here? So we have to represent the equivalent of this 2 amps with respect to some internal resistance, or by using some, so this current source equivalently it can be represented as open circuit. So directly, so the response of this 32 volts, that is 32 volts, whatever the response of this 32 volts at 3 ohm resistor is nothing but, just now also we have assumed I1 current. So I1 is the response at 3 ohm resistor due to 32 volts voltage source. And whatever the current source here, current source is simply open circuited, because indirectly we assume that the current source is inactive in the nature. So this is one simple loop. Again, one more simple loop we can generate. So there are 2 loops, and again just apply the KVL for the first loop and KVL for the second loop. So if we are assuming this current is nothing but the, because of 32 volts, I32 is the current, and anyhow this through this 3 ohm we assumed that the current is I1. So let this current is nothing but the I1 in the second loop. So whatever the balance equation by using KVL, so 32 volts is equal to drop across this. So drop across this is nothing but how much? 4 into I32 is the drop. And whatever the drop across 12 ohm, so the drop across 12 ohm is nothing but 12 into I32 minus I1 is the drop here. So drop at the 12 ohm resistor is 12 into I32 minus I1, and drop across 4 ohm resistor is 4 into I32, and this, the sum of these drops must should be equal to voltage source which is there in that particular closed path. So the energy equation is I32 into 16 minus I1 into 12 is equal to 32. Just very simple, 4 into I32 and here 12 into I32. So totally 4 plus 12, 16 I32 minus 12 into I1 is equal to 32. Similarly, now in the second loop what happens? There is no energy sources are available, all the drops only. So first one is 1 into I1 is the drop across this, and this is 3 into I1 is the drop across this, and this one is 12 into I1 minus I32. So this is the drop across 12 ohm resistor, and sum of all these values must should be equal to 0. So 12 I1 and 1 I1 and 3 I1. So 16 I1, 16 into I1 and minus 12 I32. So minus 12 into I32 is equal to 0. So like this we obtain 2 voltage balance equations, and just let us simplify this voltage balance equation. Finally we are going to get whatever the I32 current and whatever the I1 current. So only we require this value. So let us record this I1 current. So I1 is equal to 3.428 amps. So that is just we have recorded here. And second one is, second case is, so instead of 32 volts, let us add to 2 amps of current source. Now let us make inoperative the 32 volts source. So how can you make inoperative conditions for this 32 volts voltage source? By creating a short circuiting across these terminals. Just we have short circuited here, because only here in this case I am going to assume 2 amps of current source is active. So this is active. So another voltage source is short circuited. Then if it is so, this 4 ohm resistor and this 12 ohm resistor came in parallel to each other. So the equivalent of this 4 and 12 is nothing but 4 into 12 by 4 plus 12 is nothing but the 3 ohm resistor. So this value is nothing but the 3 ohm, and again 3 ohm is in parallel to this 2 amps of current source. You can convert this combination to equivalent voltage source with the help of source transformation. So this source transformation is nothing but, this is 6 volts and this is 3 ohm resistor. So finally we require this I2 current here. So 6 volts and 3 ohm and 1 ohm and 3 ohm. So totally how much of resistance here? 7 ohm resistance. So 6 volts divided by 7 ohms is nothing but 0.857 amps. So what is this current here? This current is because of a current source, and that is at 3 ohm resistance point. So let us record that current also. So I2 is equal to 0.857 amps. So totally the current I is nothing but the response, sum of the responses. So sum of the responses are I1 plus I2. So the total value is nothing but which is also equal to 4.285 amps. Already we have calculated by using fundamental principles available in the electrical engineering. So like how we are going to verify the superposition theorem. Hopefully you might have enjoyed this particular problem. Similarly, I am going to give few more problems for better understandings. Try to solve. Experience only gives the expertness in getting the solutions of electrical engineering related problems. Thank you very much. Thank you for watching this video.
Like, share and subscribe. Hit the bell icon for more updates.